So for this challenge, we're looking at a range of picture sizes, and we want to find frames that would fit these pictures. They're all quite irregularly sized, so they wouldn't fit most of the kind of typical picture frame sizes that you would get. So which ones do we choose? So what we're going to look at first of all is we want to split up these sizes into their lengths and widths. So with this input, then we can just go to the split values option and select automatic split, and this will just give us the numeric values returned in two columns. So if I go ahead to that step and show that, then this is exactly how that comes through. So we've got size split 1 and size split 2. You'll notice that we have this empty row here, and that's because we've got a 24 centimeters squared. So we just need to make this be a 24 as well. So we'll rename these to length and width, and then we'll write a calculation that overwrites it. So for width, we'd go if width equals, and this is two quotation marks with nothing in between, then we'll take the length instead. Otherwise, take the width. And now we can see that that 24 centimeters square has 24 in both the length and the width, just as we want. The only thing left to do in this instance is change the data type from being a string to being a number, and then we're ready to move on. Okay, so if we look at doing the same thing for our picture frames, so we have our sizes in a similar way with the X in between, but in this instance we've got a couple of different anomalies. So we've got some of the frames are in inches rather than centimeters. We've got a couple of those cases where they're square frames, so they have that centimeters squared. So when we try and do an automatic split, if I just show you here, then Tableau Prep isn't too sure what it should be returning. So it gives us a lot of nulls for those inches values, and it only gives us one of the sides of the rest of those. So okay, that's not what we want, so we'll probably want to do a custom split instead. So if we do a custom split, let me just show you what I would do there. So I'd use the X as the separator, and I would take all those fields, and we'll see that that gives us, everything before and after the X. Okay, so that's what I've done in the next step to give us these two split fields. Now I'm just going to rename those like we did before to length and width. We need to deal with these blanks, so that's one thing that we want to do. But before that, I've done a little calculated field to say whether it's centimeters or inches, so that we can deal with those inches values, multiplying by 2.5 in a little while. So just categorized those up so I can see that, yep, these are all the inches values, and yes, these are all the centimeter values. Okay, so what I've done as well now is to deal with the fact that I've got these centimeters squared. How do I get rid of the centimeters squared? Could I do a split? What could I do to get rid of those values? And I thought the easiest way was, probably to do a split on the CM, and just retain the first part of it, so that I can get rid of the centimeter squared. I thought about if I just remove the letters, but then you still have the 2 remaining, and you'd have a length of 252 centimeters, which wouldn't be what we meant at all. So yeah, that's the way that I decided to deal with that. And then from here, we can just remove the punctuation. And so go to clean, remove punctuation, and then we can just rename this to be the length. So okay, that's the length sorted out. So I remove the punctuation, I change it to numbers, and there we go. We were all done there. So I get rid of the original length and rename this one to be length. And then this one, we can multiply that. If it's centimeters, just remain unchanged. Otherwise, multiply it by 2.54. And then we have our different values there. Okay, so for the width, we can just go ahead and straight away remove the punctuation, remove the letters, so remove letters, remove punctuation, and that will give us just the numbers remaining in that field. And then we can do that similar calculation where we just make sure that if it's a empty row, then give us the length. Otherwise, turn our width into a number. So that's what that float is doing. If I don't have that float there, then we get an error. So because we've got our length has already been changed to a numeric value, then it's saying return a number sometimes and other times return a string. Obviously Prep wouldn't like that, so that's why we have to have that float there. But yeah, you could have played around with the order that we perform those steps in, and it wouldn't have mattered too much. And then we just need to multiply those together. So next, our next two steps in both of the branches of this workflow are very similar. We're just going to take the minimum and the maximum side from these lengths. So we just want the minimum value of the length and the width. So we do that here, and then we want the maximum value, which is just using the max function in that way. And this just means that we can match up our frames. It doesn't matter which way we've called the length and the width. We just have the minimum and the maximum side. And where we've got squares, we'll obviously have the min and the max being the same number. And finally, before we join them together, we're just going to calculate the area, which is the min times the max side. Okay. So now for our join, we're going to have two join clauses, which is going to match up all the potential frames to each picture. So we've got our min side being less than or equal to the min side of the frame, and our max side being less than or equal to the max side of the frame. And you can see that all 14 of our pictures are coming through. We're not considering two of those frames. They are too small for any of our pictures, which is absolutely fine. But our join result is 43 rows. So that means that some pictures have multiple possible frames that they would fit. So we calculate the excess to work out which one is the one we should keep. So we do the area minus 1, which is the area from the frames, minus the area, which is the picture area, and that gives us our excess. And then we're going to use an LOD to calculate for each picture. We want the minimum excess, and then we'll just use a filter to filter to just those frames. So min excess equals excess. And now you can see we're back down to 14 rows, and so we know exactly what frame should go with which picture. Okay, so that is all that we need for that challenge. I hope you enjoyed this little quirky one, and thanks very much for watching.